Welcome to our second lesson on motion in one dimension. We're going to start by taking a look at our distance and displacement values today. Now, distance is seen as the actual path length traveled. That means, let's say there was your 2 points, the one where you started from at point A and the one that you ended up at point B. But in order for you to get to point B, you traveled quite a different road apart from just a straight road. So this whole distance that you've covered is then seen as the actual path length. Now the symbol that we'll be making use of, and you'll see your textbooks do differ on this, could be capital letter D, or sometimes they indicate it as a small letter d, and some also indicate it as an x or a delta x value. Now any of these will be accepted. Your unit for your distance will always be meters. So you must remember that you must be able to convert things like centimeters and millimeters as well as kilometers back to meters. So taking centimeters to meters will end up dividing with 100. Taking millimeters to meters will end up dividing with 1,000. But when I want to take kilometers to meters, then I'll multiply with 1,000. Now your distance is a scalar quantity, and remember, scalar quantity is something that only has magnitude, and magnitude is just a fancy word for meaning size of a specific value. So when we take a look at our distance, we would see that we might have traveled from point A to point B, and this was a total for us maybe of 200 meters. But that's it. We're not going to include anything else apart from just the value with its units. Now displacement is seen as the shortest distance between the start and the finishing point. So now previously this yellow line indicated the distance. But as we said, our displacement is the shortest distance from our starting and our finishing point. That means basically it's one straight line from where we started to where we end. Now obviously if you take a look at the distance from start to finish in my white straight line here, it's far shorter compared to my distance traveled. Now our displacement on the other hand is a vector quantity. It has both a magnitude, that means a size value, as well as a direction. So taking a look again at our example, if we decided to start at point A and we would then measure our shortest distance from A to B to be 40 meters. Then we will also include, apart from the sign, the direction which our finishing point lies from our starting point. And in this case, it's to the right, or you could say eastwards. So it's 40 meters to the right, or 40 meters east, but it must have both a magnitude and a direction. Our symbol for displacement will be indicated by delta, which is a triangle, and x. That's going to go for our horizontal motion. That means to the left, to the right. And we'll use the symbol delta y if we're going to look at all of our vertical motion. That means up and down. The unit will also still be in meters, and you must know how to convert all your things like centimeters, millimeters, and kilometers back to meters. Let's go and apply this to an example. We've got John that walks 800 meters in a straight line to the right, and then he turns around immediately and walks another 1,400 meters in the opposite direction, which obviously means towards the left. Now we would need to go and calculate John's distance and his displacement. Let's first start off with his distance. Now John walked a total of 800 meters to the right, and remember now that distance do not take direction into account. It's the whole actual path length of John. That means as it goes there and back again to the left hand side, this whole distance of 800 plus the 1,400 is what he has traveled. And this ends up giving me 2,200 meters. And that's my value. Nothing else gets added to this. Now when we take a look at John's displacement, we need to make sure that we know where he started and where he ended. And obviously his shortest distance between start and finish is only this little small line, which is indicated by white. So when you're going to add up your displacement values, which is vector quantities, we are going to be making use of positive and negative signs for our direction. So that means if I'm going to see John moving towards the right-hand side, I'm going to see that as a positive value. And that means when he moves in the opposite direction, it will be a negative value. So for adding up then my displacement, which is in a horizontal direction, that's what we make delta x use of for here, we're going to have positive 800, and I'm going to put my values in brackets because it's going towards the right, and I'm going to add to that this 1400, but note he's going in an opposite direction, which is negative at the end of the day, and this gives us negative 600 meters. Now we are never allowed to leave all or any of our vector quantities in a negative value. We must always go and state this as a positive value, but with a direction. So we know that the negative actually means left. So it's positive 600 meters towards the left. You should not add your direction together with your negative sign. That means the negative multiply another negative, because left does mean negative, and that ends up giving us a positive value. That would be wrong. It must be 600 meters positively stated to the left. Now we're going to look at another scenario. Here we're going to have an athlete that runs around a square track with a sides of 400 meters each. So that means between A to B is 400 meters, B and C 400, C and D 400, and then D and A 400. We're going to take a look at each point A, B, C, D, and back at A again when he runs around the track, what will be his distance and his displacement at those specific points. Now let's start at point A. That's his very beginning, and he's just starting at point A. That means he hasn't even traveled yet, so there is no distance, and there's also thus no displacement. In our next situation, he started now at A, and he has now run up till point B. So when we're going to take a look at our distance for AB side is 400 meters. And if I've got to go and determine my displacement for this motion as well, then we'll note shortest distance between start and finish is also 400 meters, but there must be a direction, and they actually indicated to you that there is a north, east, south, and west direction. That means you must then say 400 meters, and when it goes towards our right-hand side, it actually means east. Now remember, displacement must have a value together with a direction. Now the next one is quite unique. We are now reaching point C over here. So we've traveled from A to B to C. Our distance would be the 400 meters from A to B plus another 400 meters from B to C, which is a total of 800 meters. But if we take a look at our displacement, this is our starting point at A, our finishing point at C. The shortest distance is this line in between. Now to go and calculate this value, we'll be using Pythagoras, seeing that this is a 90-degree angle between your AB and BC line. So we'll be making use of his formula of r squared is x squared was equal to x squared plus y squared, and where my x and my y is both 400 meters that would need to be squared. And at the end I'll do the square root value in order to get my r alone. Now after doing the square root, we'll find that r's distance, that's a straight point from A to C, is 565,69 rounded to 2 decimal places meters. But we'll also need to indicate direction, and that means from point A, if we take a look at our north, east, south and west, it lies in a southeast direction. So this is our direction for our displacement. Now taking a look at our next point, which is point D over here. If I go and calculate my distance, now we've traveled from A to B, from B to C. That means we're going to have the 400 meters in total here. That will be multiplied by 3 parts, the A to B, B to C and C to D, and that gives us 1,200 meters. If we take a look though at our displacement, remember it's the shortest distance from start to finish. That means we started at A, we at this point finished at D, so this is my shortest distance. And it is 400 meters that side to the south direction. And for our last one, we've started at A and we run around the whole track and we're back again at A. So that means my total distance covered will be all of the 400 meters sides, that in this case is 4, and that's a total of 1,600 meters thus covered in a distance. Our displacement, remember as we said, is always our shortest distance from start to finish. So we started and finished at the same spot, so there is no difference in distance. So therefore, our displacement is 0.